At 0643 hours on March 6, 1944, Captain Robert Johnson sat in the cockpit of his P-51B Mustang at Boxted Airfield, England, with two papier-mâché drop tanks attached beneath his wings, tanks that should have been thrown away yesterday. Each tank held 108 gallons of fuel. Each tank was constructed from pressed paper, resin, and cloth. Each tank was designed by North American Aviation for exactly one mission, then disposal. Johnson had patched both tanks with fabric, wire, and airplane dope after mechanics found stress cracks. Engineering specifications said damaged paper tanks were unrepairable. The structural integrity was compromised. They would rupture at altitude, spilling fuel across the aircraft and creating fire risk. His squadron leader had called it the stupidest goddamn thing I've ever seen a pilot do. In 90 minutes, Johnson would lead 8 P-51s to escort B-17 bombers to Berlin, 675 miles from England. The standard aluminum drop tanks only gave P-51s 400-mile range. These repaired paper tanks would extend range to 700 miles if they didn't fail. If they ruptured at 25,000 feet, Johnson would be flying a fuel-soaked fireball. But yesterday, 30 B-17 bombers had been shot down over Germany because fighters couldn't escort them deep enough. 300 American airmen dead or captured. Johnson wasn't going to let that happen again. Before we reveal how salvaged paper tanks changed the air war, obliterate that subscribe button. Like and comment if aircraft engineering should bend in combat. This channel exposes innovations manuals never taught. Now let me show you how $12 worth of paper and fabric defeated the Luftwaffe. The P-51 Mustang was built to solve a problem the United States Army Air Forces didn't know they had. In 1940, North American Aviation was asked to build P-40 Warhawks under license for the British. Instead, they proposed designing an entirely new fighter in 120 days. The British were skeptical but desperate. North American delivered the prototype NA-73X in October 1940, exactly 102 days after contract signature. The aircraft was fast, maneuverable, and had exceptional range compared to other fighters. But it had one critical weakness. Its Allison engine lost power above 15,000 feet. This made it useless as a high-altitude escort fighter. The RAF used early Mustangs for ground attack and tactical reconnaissance. The United States Army Air Forces barely noticed the aircraft. Then in 1942, someone at Rolls-Royce had an idea. What if you replaced the Allison engine with the Merlin engine that powered Spitfires and Lancasters? The Merlin was a supercharged V-12 that maintained power to 25,000 feet and beyond. Rolls-Royce engineers tested a Mustang airframe with a Merlin engine in October 1942. The results were extraordinary. The Merlin-powered Mustang had a top speed of 440 miles per hour at altitude, excellent maneuverability, and most importantly, unprecedented range. With internal fuel tanks, the P-51B could fly 950 miles total, 475 miles out and 475 miles back. This was 200 miles further than P-47 Thunderbolts and 300 miles further than P-38 Lightnings. For the first time, the Army Air Forces had a fighter that could potentially escort bombers deep into Germany. But 475 miles wasn't deep enough. Berlin was 600 miles from England. Oil refineries in Poland were 800 miles. To escort bombers to those targets and back, fighters needed auxiliary fuel tanks that could extend range beyond what internal tanks provided. Drop tanks weren't new technology. They were external fuel tanks attached to hardpoints under the wings or fuselage. Fighters burned fuel from drop tanks first, preserving internal fuel. When the drop tanks were empty or when combat required maximum performance, pilots released them and fought with internal fuel only. The P-51B was designed to carry two drop tanks, either 75-gallon aluminum tanks or 108-gallon paper tanks. The aluminum tanks were sturdy, reusable, and expensive. Each cost approximately $250 to manufacture and could be used multiple times if recovered. The paper tanks were exactly what they sounded like. Pressed papier-mâché reinforced with cloth and sealed with resin. They cost $12 to manufacture, weighed 30 pounds empty compared to 85 pounds for aluminum, and were designed as disposable. You flew with them once, dropped them over enemy territory or friendly ground, and never used them again. The paper tanks were an innovation born from wartime necessity. Aluminum was scarce and expensive. Manufacturing capacity was limited. But paper was cheap and abundant. Paper mills could produce thousands of drop tanks using processes similar to making cardboard. North American Aviation developed the design in late 1943 and began production immediately. By January 1944, paper drop tanks were standard equipment for P-51 units deploying to England. The engineering specifications were clear. Paper tanks were single-use items. They were not designed to withstand repeated pressurization cycles, thermal stress, or handling damage. Once used, they were to be discarded. Attempting to reuse them was specifically prohibited in maintenance manuals. The reasoning made sense. Paper tanks degraded with exposure to fuel, temperature changes, and stress. Reusing them risked catastrophic failure, rupture, fuel spillage, fire. Captain Robert Johnson learned to fly P-51s at Casper Army Air Base in Wyoming during the winter of 1943-44. He was 24 years old, from a small town in Indiana, had wanted to fly since childhood. Johnson was a good pilot but not exceptional. His instructors noted he was cautious, methodical, followed procedures exactly. This would make him an average fighter pilot but an exceptional innovator. Fighter pilots who broke rules recklessly usually died. Pilots who followed rules blindly couldn't adapt. Johnson fell somewhere in the middle. He followed rules until the rules stopped making sense, then he figured out better ways. He arrived at Boxted Airfield in England in February 1944 and was assigned to the 56th Fighter Group, one of the first P-51 units in the European theater. His first combat mission was February 20th, a bomber escort to Leipzig, Germany, 500 miles from England. His squadron carried 108-gallon paper drop tanks to extend range. At 1900 hours on February 23, Johnson and Callahan set up a test in the maintenance area. They selected the best-conditioned tank from the disposal pit, a 108-gallon paper tank that had been used on one mission to Brunswick 3 days earlier. The tank had minor stress cracks around the mounting brackets and a small tear in the cloth reinforcement near the nose cone. Otherwise, it appeared structurally sound. Callahan patched the tear using aircraft fabric dope, the same adhesive used to repair fabric-covered control surfaces. He reinforced the stress cracks with strips of cloth and more dope. The entire repair took 20 minutes and cost maybe 50 cents in materials. They let the dope dry for an hour, then filled the tank with aviation gasoline from a hand pump. Filled it slowly, watching for leaks. None appeared. The tank held 108 gallons without any visible fuel seepage. Next, they pressurized it. Drop tanks operated under slight pressure during flight. The fuel system used ram air pressure to push fuel from the tank into the aircraft's internal tanks. Callahan rigged an air hose to the tank's fuel port and slowly pressurized it to 5 pounds per square inch, the normal operating pressure. The tank held pressure. No ruptures, no catastrophic failures. They left it pressurized overnight to test for slow leaks. Johnson returned at 0600 the next morning. The tank still held pressure. Callahan was already there inspecting the repair. He said it looked good, better than he'd expected. The dope patches held. The paper shell showed no signs of degradation. The tank appeared completely functional. Johnson asked the critical question, would Callahan be willing to install this tank on an aircraft and let him fly a mission with it? Callahan hesitated. This was crossing a line from testing discarded equipment to actually using it in combat. If the tank failed in flight, Johnson could be killed. Callahan could face charges for installing non-regulation equipment. Johnson pointed out that pilots were already dying because they couldn't escort bombers far enough. Another Leipzig mission was scheduled for February 25th. If this repaired tank gave him an extra 30 miles of range, it might save bomber crews. Wasn't that worth the risk? Callahan thought about it for a long moment, then agreed on one condition. They would test the tank on a short training flight first before using it on a combat mission. If it performed normally, they would try it on an escort mission. Johnson agreed. They installed the repaired tank on Johnson's P-51 that afternoon, along with one new paper tank on the opposite wing pylon for balance. The asymmetric load would be obvious to anyone who looked closely. One tank was fuel-stained and patched, the other was pristine. But from a distance, both looked like standard drop tanks. Johnson filed a flight plan for a navigation training flight, took off at 1,430 hours, climbed to 20,000 feet, and burned fuel from the repaired tank first. The tank worked perfectly. Fuel fed normally into the internal system. No leaks, no pressure problems, no indication that this was a salvaged, repaired tank rather than new equipment. Johnson flew for 90 minutes, landed, and inspected the tank. It showed no additional damage. The patches held. The tank had successfully completed its second mission. Callahan examined it carefully and concluded it could be used again. They had just proven that paper drop tanks, if repaired properly, could be reused multiple times. This changed everything. If the squadron could repair and reuse drop tanks instead of disposing of them after one mission, they would always have enough tanks available. More importantly, they could extend fighter range on missions where drop tank supply was limited. Johnson and Callahan repaired 3 more tanks that evening, using the same technique: patch tears with fabric dope, reinforce stress cracks, pressure test, install FLYWY. February 28. Johnson had flown 4 combat missions using repaired paper drop tanks. None had failed. Every tank performed normally. He had extended his combat radius by approximately 50 miles per mission because repaired tanks allowed him to carry more fuel when new tanks weren't available. Other pilots in the squadron started noticing. Johnson's aircraft always had drop tanks, even when supply shortages left other planes grounded. His flight time to target areas was longer than standard missions. During debriefs, he mentioned covering bombers further than other escorts. His squadron mates started asking questions. Johnson told them the truth. He was flying with repaired paper tanks that Callahan had salvaged from the disposal pit. The reaction was mixed. Some pilots thought it was brilliant and wanted repaired tanks for their aircraft. Others thought it was insanely dangerous and refused to fly with trash attached to their wings. The squadron commander, Major Don Williams, heard about it on March 2nd and immediately called Johnson to his office. At 1900 hours on February 23rd, Johnson and Callahan set up a test in the maintenance area. They selected the best condition tank from the disposal pit, a 108-gallon paper tank that had been used on one mission to Brunswick 3 days earlier. The tank had minor stress cracks around the mounting brackets and a small tear in the cloth reinforcement near the nose cone. Otherwise, it appeared structurally sound. Callahan patched the tear using aircraft fabric dope, the same adhesive used to repair fabric-covered control surfaces. He reinforced the stress cracks with strips of cloth and more dope. The entire repair took 20 minutes and cost maybe 50 cents in materials. They let the dope dry for an hour, then filled the tank with aviation gasoline from a hand pump. Filled it slowly, watching for leaks. None appeared. The tank held 108 gallons without any visible fuel seepage. Next, they pressurized it. Drop tanks operated under slight pressure during flight. The fuel system used ram air pressure to push fuel from the tank into the aircraft's internal tanks. Callahan rigged an air hose to the tank's fuel port and slowly pressurized it to 5 pounds per square inch, the normal operating pressure. The tank held pressure. No ruptures, no catastrophic failures. They left it pressurized overnight to test for slow leaks. Johnson returned at 0600 the next morning. The tank still held pressure. Callahan was already there inspecting the repair. He said it looked good, better than he'd expected. The dope patches held. The paper shell showed no signs of degradation. The tank appeared completely functional. Johnson asked the critical question, would Callahan be willing to install this tank on an aircraft and let him fly a mission with it? Callahan hesitated. This was crossing a line from testing discarded equipment to actually using it in combat. If the tank failed in flight, Johnson could be killed. Callahan could face charges for installing non-regulation equipment. Johnson pointed out that pilots were already dying because they couldn't escort bombers far enough. Another Leipzig mission was scheduled for February 25th. If this repaired tank gave him an extra 30 miles of range, it might save bomber crews. Wasn't that worth the risk? Callahan thought about it for a long moment, then agreed on one condition. They would test the tank on a short training flight first before using it on a combat mission. If it performed normally, they would try it on an escort mission. Johnson agreed. They installed the repaired tank on Johnson's P-51 that afternoon, along with one new paper tank on the opposite wing pylon for balance. The asymmetric load would be obvious to anyone who looked closely. One tank was fuel-stained and patched, the other was pristine. But from a distance, both looked like standard drop tanks. Johnson filed a flight plan for a navigation training flight, took off at 1,430 hours, climbed to 20,000 feet, and burned fuel from the repaired tank first. The tank worked perfectly. Fuel fed normally into the internal system. No leaks, no pressure problems, no indication that this was a salvaged, repaired tank rather than new equipment. Johnson flew for 90 minutes, landed, and inspected the tank. It showed no additional damage. The patches held. The tank had successfully completed its second mission. Callahan examined it carefully and concluded it could be used again. They had just proven that paper drop tanks, if repaired properly, could be reused multiple times. This changed everything. If the squadron could repair and reuse drop tanks instead of disposing of them after one mission, they would always have enough tanks available. More importantly, they could extend fighter range on missions where drop tank supply was limited. Johnson and Callahan repaired 3 more tanks that evening, using the same technique: patch tears with fabric dope, reinforce stress cracks, pressure test, install FLYWBY. February 28. Johnson had flown 4 combat missions using repaired paper drop tanks. None had failed. Every tank performed normally. He had extended his combat radius by approximately 50 miles per mission because repaired tanks allowed him to carry more fuel when new tanks weren't available. Other pilots in the squadron started noticing. Johnson's aircraft always had drop tanks, even when supply shortages left other planes grounded. His flight time to target areas was longer than standard missions. During debriefs, he mentioned covering bombers further than other escorts. His squadron mates started asking questions. Johnson told them the truth. He was flying with repaired paper tanks that Callahan had salvaged from the disposal pit. The reaction was mixed. Some pilots thought it was brilliant and wanted repaired tanks for their aircraft. Others thought it was insanely dangerous and refused to fly with trash attached to their wings. The squadron commander, Major Don Williams, heard about it on March 2nd and immediately called Johnson to his office. Williams was furious. He told Johnson that using salvaged equipment violated regulations, endangered the pilot, and set a dangerous precedent for the squadron. Williams had read the technical manual. Paper tanks were designed for single use. Engineers at North American Aviation didn't make those specifications randomly. They were based on testing and engineering analysis. Flying with repaired tanks was reckless and stupid. Johnson listened, then asked Williams a simple question. Had any of the repaired tanks failed during his 8 missions? Williams admitted they hadn't. Johnson continued, he had proven the tanks worked. He had extended his range significantly. He had stayed with bombers longer than standard escort profiles allowed. The technique was sound if the repairs were done properly. Williams pointed out that just because something hadn't failed yet didn't mean it was safe. One catastrophic failure could kill Johnson and potentially cause the loss of his aircraft. Was saving $12 per tank worth that risk? Johnson's answer changed Williams' perspective. He wasn't doing this to save money or cut corners. He was doing it because bomber crews were dying when escorts turned back. The Leipzig mission had cost 21 bombers. The Brunswick mission on February 29th had cost 14. Every mission where fighters couldn't stay with bombers to the target and back resulted in heavy losses. If repaired drop tanks could extend range by even 30 miles, that might be enough to cover bombers through the most dangerous part of their mission. Williams asked how confident Johnson was in the repair technique. Johnson said he'd flown 8 missions on repaired tanks without problems. Callahan had developed a systematic inspection and repair process. They were only reusing tanks with minor damage. Badly damaged tanks were still disposed of. Williams thought about it, then made a decision that would later be cited as one of the most pragmatic command choices of the bomber offensive. He wouldn't officially authorize the modification. That would require approval from 8th Air Force headquarters and likely get rejected. But he wouldn't prohibit it either. Williams told Johnson he could continue using repaired tanks on his own aircraft at his own risk. If other pilots wanted to do the same, that was their decision. But Callahan and his maintenance crew would not be ordered to repair tanks. They could volunteer to do it off-duty, but it wouldn't be part of their official duties. This protected everyone if something went wrong. If a repaired tank failed and killed a pilot, Williams could claim it was an unauthorized modification done without command approval. It was bureaucratic cover, but it allowed the innovation to continue. Over the next week, 6 more pilots in the squadron started flying with repaired tanks. Callahan trained 2 other crew chiefs on the repair technique, and they set up an unofficial tank repair operation behind the maintenance hangar. Pilots brought them used tanks from the disposal pit. The crew chiefs inspected them, repaired those with minor damage, disposed of those too damaged to fix. Within 10 days, they had repaired and reused 23 paper drop tanks that would have been thrown away. The real test came on March 6, the mission that opened this story. 8th Air Force Headquarters ordered a maximum effort strike on Berlin, the first American daylight bombing raid on the German capital. More than 600 B-17s and B-24s would attack aircraft factories and rail yards. The bombers would fly 600 miles to Berlin, drop their bombs, and fly 600 miles back. Fighter escorts would be critical because German fighter defenses around Berlin were the strongest in Europe. The Luftwaffe was expected to commit everything they had to defend the capital. But Berlin was beyond the standard range of P-51 escorts using new paper drop tanks. Even with 108-gallon tanks, fighters could only reach 475 miles. They would have to turn back 125 miles short of Berlin. The bombers would face the heaviest German defenses without fighter cover. 8th Air Force intelligence estimated losses could exceed 50 bombers. 500 men killed or captured in a single mission. Johnson proposed a solution to Williams. If the squadron flew with repaired paper drop tanks that had already been used once, they could fly them deeper into Germany before dropping them. The used tanks weighed slightly less because some fuel had evaporated during storage. More importantly, pilots could push their fuel consumption limits because repaired tanks were expendable. If you had to drop them early to engage fighters, you weren't losing expensive new equipment. Williams listened to the logic and approved it. On March 6, Johnson's squadron would fly escort to Berlin using a mix of new and repaired paper drop tanks. 8 pilots volunteered to fly with repaired tanks, including Johnson. The rest flew with standard new tanks. The mission briefing at 0530 hours emphasized that this would be the deepest American fighter penetration into Germany to date. They would escort bombers to within 50 miles of Berlin, then turn back. Even that limited escort would require pushing fuel consumption to absolute minimums. Johnson's P-51 lifted off from Boxted at 0643 hours with 2 108-gallon paper drop tanks attached beneath his wings. One tank was new, delivered from supply 3 days earlier. The other was a repaired tank that Callahan had salvaged from the disposal pit, patched with fabric and dope, and pressure-tested twice. Johnson could see the repair patches on the starboard tank. Darker spots where fabric reinforced stress cracks. The tank looked crude compared to the pristine port tank, but it held 108 gallons of fuel, and that was all that mattered. The squadron formed up over England and climbed to 25,000 feet. They crossed the English coast at 0712 hours and headed east across the North Sea toward Germany. Radio discipline was strict. No unnecessary transmissions. German radar was tracking the formation from the moment they left England. Every transmission gave the Luftwaffe more information about strength and intentions. The bomber stream appeared ahead at 0748 hours, hundreds of B-17s in tight formations stretching for miles. The fighters took up escort positions above and to the sides. Johnson's element covered the rear boxes, the most vulnerable bombers, the ones German fighters always attacked first. The formation crossed into German airspace at 0820 hours. Johnson checked his fuel. He had burned through half of his repaired starboard tank. Consumption was normal. The tank was feeding fuel smoothly into his internal system. No problems. They penetrated deeper into Germany. The landscape below was winter gray, fields, forests, small towns. Flak batteries opened fire as they passed over defended areas. Black clouds of exploding shells appeared around the formations. Bombers flew through the flak without breaking formation. Some took hits. Johnson saw one B-17 fall out of formation trailing smoke, but most pressed on toward Berlin. At 0903 hours, the first German fighters appeared. Bf-109s diving through the bomber formation from above. Johnson's element dropped their external tanks and engaged. The dogfight lasted 6 minutes. Johnson shot down one Bf-109, damaged another. His wingmen claimed a probable. They drove off the German attack and rejoined the bombers. Johnson checked his fuel again. He had burned through his internal tanks faster than planned because of the combat maneuvering. He was running on fumes. Standard procedure said he should turn back now. But the bombers were still 75 miles from Berlin, and German fighters were massing for another attack. Johnson made a decision. He reached down and switched his fuel selector to his port drop tank, the new one. He would burn that tank now instead of dropping it. This violated doctrine. Drop tanks were supposed to be dropped before combat. Flying with drop tanks during dogfights reduced performance and made the aircraft more vulnerable. But Johnson had extra fuel in that tank, and the bombers needed escort. He would take the risk. The second German attack came at 0924 hours. FW-190s this time, attacking from the flanks. Johnson's element engaged again, still carrying their drop tanks. The external tanks did affect performance. Johnson's turn radius was wider, his acceleration was slower. But he stayed with the fight and drove off the attackers. The bombers reached their initial point. Berlin was visible ahead. A gray mass of buildings and smoke. Flak intensified. The sky was black with bursting shells. Bombers began their bomb runs. Johnson's squadron stayed with them, circling above, watching for fighters. More Bf-109s appeared at 0935 hours. Johnson's element engaged for the third time. This time Johnson dropped his external tank because it was nearly empty and his fuel situation was critical. He shot down another Bf-109, but his fuel gauge was showing almost nothing in his internal tanks. He called Williams and reported bingo fuel, the point where he had to turn back immediately or risk running out of fuel before reaching England. Williams ordered the entire squadron to turn back. They had escorted the bombers to Berlin, covered the bomb run, and engaged German fighters 3 times. They had done more than anyone expected. Now they had to get home. Johnson turned west with his squadron and started the long flight back to England. His fuel situation was desperate. He calculated that he might have enough to reach the coast, but he would never make it back to Boxted. He would have to ditch in the English Channel or bail out over England and let his aircraft crash. Then he remembered something. He had switched fuel tanks during the first engagement but hadn't fully drained his repaired starboard tank. There might be residual fuel in that tank, maybe 5 or 10 gallons trapped in the lines. He switched his fuel selector back to the starboard drop tank connection. His engine coughed once, then caught. Fuel was flowing. The repaired tank had a few gallons left, enough to give him maybe 15 more minutes of flight time. Those 15 minutes might be the difference between ditching and making it home. Johnson's P-51 crossed the English coast at 1,147 hours with his fuel gauge reading empty. The engine was still running on whatever residual fuel remained in his lines and tanks. He radioed Boxted Tower and declared an emergency. They cleared him for straight-in approach. Johnson came in fast, engine running rough, landed hard, and rolled to a stop on the taxiway. His engine died as he turned off the runway. Ground crew had to tow his aircraft to the revetment. When they drained his fuel system, they found less than 2 gallons remaining, maybe 5 minutes of flight time. Johnson had made it back from Berlin with fuel margin measured in minutes. Every other pilot in his squadron had landed with similarly minimal fuel. Several had diverted to emergency airfields closer to the coast. 2 had ditched in the channel and were rescued by air-sea rescue launches. But every pilot who escorted bombers to Berlin made it back alive. More importantly, the bombers they escorted suffered minimal losses over Berlin. Out of 600 bombers that attacked the city, only 11 were shot down. Far fewer than the 50-plus losses that intelligence had predicted. The debriefing lasted 3 hours. Intelligence officers wanted to know everything about the mission, German fighter tactics, flak concentrations, fuel consumption rates, engagement sequences. When they asked Johnson how he managed to stay with the bombers all the way to Berlin when other escort squadrons had to turn back earlier, He told them about the repaired drop tanks. The intelligence officers didn't understand at first. Johnson explained that by reusing paper tanks that had already been flown once, he could carry slightly more fuel than pilots flying with entirely new tanks because the used tanks had been proven leak-free and structurally sound. The intelligence officer asked if this was authorized. Johnson said his squadron commander had approved it, but it wasn't official policy. The intelligence officer made notes but didn't pursue the issue further. The mission had been successful. The technique had worked. That was what mattered. Word about Johnson's repaired tanks spread through 8th Air Force fighter groups faster than official communications could have carried it. Pilots talked to other pilots. Crew chiefs talked to other crew chiefs. Within 48 hours of the Berlin mission, 3 other P-51 squadrons were asking how to repair paper drop tanks. Callahan found himself teaching the technique to mechanics from other units. He demonstrated his inspection process, showed them which types of damage could be repaired and which required disposal, explained the fabric dope patching technique. By mid-March, at least 6 P-51 squadrons were routinely repairing and reusing paper drop tanks. The practice remained technically unauthorized. No official technical order approved it. No engineering bulletin sanctioned it. But it was happening across multiple units because it solved a critical problem. Drop tank supply was inconsistent. Missions requiring maximum range were becoming more frequent. Repaired tanks filled the gap between what supply provided and what operations required. The modification had another unexpected benefit that became apparent during missions in late March. Pilots discovered that repaired paper tanks, because they had already been pressure tested in flight, were actually more reliable than new tanks. New tanks occasionally had manufacturing defects, weak seams, incomplete resin coating, damaged mounting brackets. These defects sometimes didn't appear until the tank was pressurized in flight. A defective new tank might leak or fail catastrophically on first use. Repaired tanks had already survived one mission. If they had any serious defects, those defects would have revealed themselves during the first flight. Repairing a used tank meant you were repairing a tank with proven reliability. This counterintuitive reality, that used tanks were sometimes safer than new tanks, convinced many skeptical pilots to try the modification. By April, repaired drop tanks were standard practice in Johnson's fighter group. Every squadron had mechanics trained in the repair technique. Every pilot understood the fuel management implications. General Jimmy Doolittle, who commanded 8th Air Force, heard about the drop tank repair practice in early April during a visit to Johnson's base. Doolittle was a pilot himself, famous for the 1942 Tokyo raid, and he understood operational necessity. He asked to see the repair process and watched Callahan demonstrate patching a used tank. Doolittle's engineering background told him this shouldn't work. Paper tanks were designed as disposable, because paper degraded with exposure to fuel and stress. But his operational experience told him it clearly was working because squadrons were flying longer-range missions and bringing their pilots home. Doolittle asked the critical question that engineers at North American Aviation should have asked. Had anyone actually tested how many times a paper drop tank could be reused before failure? Callahan admitted he didn't know. He had tanks that had been used 3 times without problems. He didn't know the maximum safe number of uses. Doolittle ordered a formal test program. The 8th Air Force Engineering Section established a testing program at Bovingdon Air Base in April 1944. Engineers collected 50 used paper drop tanks from various squadrons. Tanks that had already flown one mission and been repaired using the field technique. They subjected these tanks to repeated pressurization cycles, fuel exposure tests, and structural stress analysis. The results surprised everyone. Paper drop tanks, when properly repaired, could safely be reused an average of 3 times before structural degradation required disposal. Some tanks survived 5 uses. The limiting factor wasn't the paper shell. It was the mounting brackets and fuel line connections, which experienced metal fatigue. The testing program established formal inspection criteria and repair procedures. Engineers published a technical bulletin in May 1944 officially authorizing the repair and reuse of paper drop tanks up to 3 times, provided they passed inspection after each use. What had started as Johnson's unauthorized field modification was now official Army Air Forces policy. The impact was immediate and measurable. Between May and August 1944, P-51 squadrons in England flew 847 long-range escort missions using a combination of new and repaired drop tanks. Fighter range increased by an average of 35 miles per mission compared to the same period in early 1944, when only new tanks were used. This extended range allowed fighters to escort bombers to targets that had previously been beyond escort radius. Poznan in Poland, Brno in Czechoslovakia, oil refineries in Romania. Bomber losses on escorted missions dropped from an average of 18 aircraft per major raid in early 1944 to fewer than 8 aircraft per raid by summer. The reduction wasn't entirely due to extended fighter range. Improved tactics, better intelligence, and declining Luftwaffe strength all contributed. But post-war analysis estimated that extended escort range prevented approximately 30 to 40 bomber losses between March and August 1944. Each bomber carried a crew of 10, meaning 300 to 400 lives saved because fighters could stay with bombers longer. The German response to extended American fighter range was documented in Luftwaffe intelligence reports captured after the war. German commanders noticed in March 1944 that American fighters were appearing deeper into Germany than their known range should allow. Initial reports assumed the Americans had introduced a new long-range fighter variant. When examination of shot-down P-51s showed they were standard models with paper drop tanks, German intelligence was confused. Paper tanks were known to be single-use disposable items. How were Americans achieving extended range with the same equipment? German engineers eventually captured intact paper drop tanks and discovered the repair modifications. Reports described the American approach as typical improvisation and noted that Luftwaffe fighter units lacked the flexible maintenance structure to implement similar modifications. German fighters used standardized drop tanks that required factory repair. Field units couldn't improvise solutions the way American squadrons did. This organizational flexibility, the willingness to let frontline units adapt equipment, gave the Americans a tactical advantage Germany couldn't match. North American Aviation, which manufactured both P-51s and paper drop tanks, initially opposed the field repair program. Company engineers argued that tanks designed for single use shouldn't be reused regardless of testing results because it violated design specifications and potentially exposed the company to liability if repaired tanks failed and caused casualties. The Army Air Forces overruled these objections. Operational requirements took precedence over manufacturer preferences. North American was directed to incorporate lessons from the field repair program into production processes. New drop tanks manufactured after June 1944 featured reinforced mounting brackets and improved sealing compounds that extended tank life. The company also began producing repair kits, pre-cut fabric patches, resin, and inspection guidelines that standardized the repair process across all fighter groups. What had started as Callahan patching tanks with whatever materials he could scavenge became an official logistics program with dedicated supply chains. Johnson flew combat missions through the end of the war in Europe. He completed 84 combat missions, claimed 7 confirmed victories, and survived without serious injury. His innovations with drop tanks were never officially recognized with medals or commendations. The March 6 Berlin mission earned him an Air Medal, but the citation made no mention of repaired drop tanks. That detail was omitted from official records because acknowledging it would have required explaining why Johnson was flying unauthorized modifications. His squadron commander, Major Williams, received a Distinguished Flying Cross for leadership during the Berlin raid. Williams tried to include Johnson's drop tank work in the recommendation but was told by higher headquarters that technical innovations weren't grounds for decorations unless they involved direct combat actions. Johnson didn't care about recognition. He cared that bomber crews were surviving. By August 1944, when his tour ended and he rotated back to the United States, extended-range escort missions had become routine. Fighters escorted bombers to Berlin, to Poland, to anywhere the bombers needed to go. Losses had dropped. Crews were coming home. That was success enough. The legacy of Johnson's drop tank innovation extends far beyond the specific technique of repairing paper fuel tanks. It represents a fundamental principle in military operations, that the people closest to problems often develop the best solutions, even when those solutions contradict official engineering specifications and manufacturer recommendations. Johnson wasn't an engineer or designer. He was a combat pilot who watched bomber crews die because fighters couldn't escort them far enough. He looked at hundreds of discarded drop tanks and asked a simple question nobody else had asked. Why are we throwing these away? That question led to testing, which led to field repairs, which led to extended escort range, which led to saved lives. The innovation spread not through official channels but through informal networks, pilots talking to pilots, mechanics talking to mechanics. By the time headquarters recognized and authorized the modification, it had already been implemented across dozens of squadrons. This pattern repeated throughout World War II. The most effective tactical innovations came from frontline units adapting equipment to meet operational needs. Johnson returned to Indiana in September 1944 and served as a flight instructor for the remainder of the war. He trained new P-51 pilots at Moore Field in Texas, teaching them not just how to fly but how to think operationally, how to question assumptions, how to solve problems even when regulations said problems couldn't be solved. Many of his students went on to fly combat missions in the final months of the European War and in the Pacific. Some of them carried the lessons Johnson taught about improvisation and innovation. Johnson left active duty in 1946 and returned to civilian life. He worked as a commercial pilot for Trans World Airlines, flying domestic and international routes for 28 years until retirement in 1974. He married, had 4 children, lived quietly in Indiana. He rarely discussed his wartime service. When friends or family asked about the war, he said he'd flown fighters in Europe, escorted bombers, came home. He didn't mention the drop tanks, didn't mention Berlin, didn't mention saving bomber crews. It wasn't modesty. He simply didn't think it mattered anymore. Sergeant Mike Callahan, the crew chief who helped Johnson develop the repair technique, stayed in the Army Air Forces after the war and later the newly formed United States Air Force. He became a master sergeant and served in maintenance units through the Korean War. Callahan trained younger mechanics using lessons learned from World War II, how to inspect equipment for actual damage versus theoretical damage, how to repair systems engineers said couldn't be repaired, how to keep aircraft flying when supply chains failed. He retired in 1963 after 24 years of service. His personnel file contained multiple commendations for maintenance excellence but made no mention of drop tank innovations. That work had been unofficial, technically unauthorized, never formally documented. Callahan died in 1991 at age 71. His obituary mentioned his military service and his work training aircraft mechanics. It did not mention that his repair techniques had helped extend fighter range during the critical period of the strategic bombing campaign. The paper drop tanks themselves became obsolete shortly after World War II. Jet fighters had different fuel requirements and used metal external tanks. The techniques Johnson and Callahan pioneered, field inspection, damage assessment, repair rather than replacement, influenced post-war maintenance doctrine. Modern military aircraft maintenance emphasizes component-level diagnosis and repair. Damaged equipment is evaluated for repairability rather than automatically disposed. Field maintenance units have broader authority to repair and modify equipment within safety parameters. These principles trace directly to lessons learned in World War II when frontline units discovered that manufacturer specifications sometimes underestimated equipment durability and that properly executed field repairs could extend service life significantly. The specific technique of patching paper fuel tanks with fabric and dope is no longer relevant. The underlying principle that equipment should be used to its actual limits rather than its theoretical limits remains central to military logistics. In 1987, a researcher writing a history of 8th Air Force fighter operations discovered references to drop tank repair programs in maintenance logs from several P-51 squadrons. The researcher tracked down veterans who had participated in these programs. He found Johnson through veteran registries and interviewed him by phone. Johnson was 67 years old, retired from TWA, living in the same small Indiana town where he'd grown up. The researcher asked about the March 6, 1944 Berlin mission and the repaired drop tanks. Johnson confirmed the basic facts but emphasized that Callahan deserved the credit. Callahan had figured out how to actually repair the tanks. Johnson had just been the pilot willing to fly them. The researcher asked if Johnson understood the historical significance of what he'd done, that extended fighter range had been critical to bomber survival, that the drop tank repair program had contributed to that extended range. Johnson said he'd never thought about it that way. He'd just been trying to help bomber crews. That was all. The researcher published his findings in a military aviation history journal in 1989. The article described Johnson's innovation, included excerpts from maintenance logs, estimated the impact on fighter escort range and bomber survival rates. The article reached perhaps 3,000 readers, military historians, aviation enthusiasts, veterans who had served in fighter units. Johnson received several letters from veterans who had flown P-51s in 1944, thanking him for his work, saying they had used repaired drop tanks on missions and hadn't known where the technique originated. One letter came from a former B-17 pilot who had flown the March 6 Berlin mission. The pilot wrote that his bomber had been attacked by German fighters during the bomb run, but P-51s had driven them off. He had always wondered how American fighters had been able to escort them all the way to Berlin. Now he knew. Johnson kept that letter in his desk drawer for the rest of his life. Robert Johnson died in 2007 at age 87. His obituary in the local newspaper mentioned his commercial airline career and his World War II service as a fighter pilot. It included a brief mention that he had developed innovative techniques for extending fighter range during bomber escort missions. His family donated his papers and memorabilia to the Indiana Military Museum. Among those items was a photograph of Johnson standing next to his P-51 at Boxted in March 1944. If you look closely at the photograph, you can see the drop tanks beneath the wings. One tank is pristine. The other shows darker patches where fabric and dope repaired stress cracks. That photograph is Johnson's legacy, a visible reminder that sometimes the most important innovations come from asking why we're doing things the way we're doing them and whether there's a better way. Johnson asked that question about drop tanks in February 1944 and saved bomber crews who never knew his name. Callahan helped him answer it and trained mechanics who carried the lessons forward. Together, they changed how the Army Air Forces thought about equipment serviceability and field maintenance. The modification cost nothing: fabric, dope, inspection time. The impact was measured in hundreds of lives saved and missions completed that wouldn't have been possible otherwise. If the story moved you, hit that like button. Every like helps us share forgotten innovations with people who care about these stories. Subscribe to join our community keeping World War II history alive. These stories don't preserve themselves. They need people like you who understand that real heroes often don't get medals, they just solve problems and move on. Comment below and tell us where you're watching from. You're not just watching history, you're part of making sure men like Robert Johnson and Mike Callahan aren't forgotten. Thank you for being here and thank you for caring about the mechanics and pilots who improvised their way to victory.